Kelvin Harikesh Chen, and today we'll present our project of improving patient cohort identification by retrieving social determinants of health components from clinical notes. According to research, only 20% of persons' health outcomes may be attributed to event that occurs at clinician's office. The remainder is determined by individual behavior and the settings and circumstances of people's living environments. These variables are referred as social determinants of health, SDoH. The SDoH are social and economic factors that can influence individuals' overall health. These factors can influence things like access to education, job opportunities, income, and living conditions. In observational research, the SDoH are studied to understand how they impact the health outcomes of individuals or the population. The research on SDoH can help researchers identify potential interventions or policies that could improve health outcomes and reduce health disparities. Cohort identification is an important step in observational research because it allows researchers to identify a group of individuals who share certain characteristics or experiences, and then study how those characteristics or experiences impact the health outcomes. This is important because it allows researchers to isolate specific factors and may be contributing to health outcomes and to better understand the relationships between different variables. By identifying and studying well-defined patient cohorts, researchers can gain valuable insights that can be used to develop more effective interventions and treatment. A reliable collection of SDoH data at the point of care can help clinicians provide personalized recommendations to their patients. By understanding the SDoH of their patients, clinicians can tailor the recommendations to address the specific SDoH factor that may be impacting the individual's health. For example, a clinician might recommend a low-cost exercise program to a patient who lives in a low-income neighborhood, or refer to transportation programs if they are not able to walk. The social determinants of health data is collected in electronic health records and is often in an unstructured format. This means that data is not organized in a consistent or standardized format, making it more difficult to analyze and interpret. SDoH data in EHRs can be recorded as free text notes in a clinical note, or some structured domains also has the SDoH component. It is challenging to identify and extracting SDoH from EHR, as there might not have a consistent way or to locate the relevant information. And the current cohort identification tools, SDoH data is always missing. There is a gap to extract SDoH from unstructured EHR data for further observational research analyses. To overcome this challenge, researchers can use information retrieval and natural language processing to extract the unstructured notes in electronic health records and identify mentions of SDoH-related elements. We aim to build a cohort extraction tool that can help identifying patient cohort using both unstructured and structured data. This cohort identification tool will be able to search relevant SDoH component that is not in a structured format and return the relevant patient structured information and clinical notes for researchers to review it. Information retrieval techniques could help us to achieve this goal. The potential users will include first, researchers who wish to extract cohort of specific patient for a preliminary exploratory analysis, include chart review or other observational research. Second, electronic health record systems that could implement such search models in a live EHR during the clinical care and provide clinical decision support. Third, Insurance companies might be interested in doing observational research on analyzing how SDoH-related data will influence the cost and the payment.
So I'll start us off with a brief overview of how the system works. So we start with the Mimic3 database. We extract a bunch of discharge notes from that, and then we perform indexing and ranking on those discharge notes. And we also use structured data to add an option to filter which documents can be returned by the retrieval tool. And then we have a front end that the user can use to put in queries and filters and to view the data that is returned. So the major steps involved: first, we had to build the local database in our computers, so we had to install Mimic3 and then build an SQL database on top of it. Then we had to create a corpus and a TF-IDF sparse matrix for all the discharge notes present in the database. And then we built a vector space retrieval tool. And then we produced some evaluations based on some annotations that we produced. So a little bit about the Mimic3 database. It is a large de-identified health-related database with lots of different EHR information. It has 40,000 plus patients, and it has a combination of structured and unstructured data. And in particular, we are looking at discharge summary reports, which are in the form of raw text. So we have to end up doing an actual proper retrieval tool on it as opposed to simply filtering out columns. So about the vector space model, we used a stemmer to pre-process our data, and we also removed numbers and performed case folding. We also created a corpus to keep track of all the tokens that were being collected, and we kept the TF-IDF vectors in the form of a large file that we then retrieve while using the retrieval tool. So here's the overall workflow. We begin at the bottom left with a user that gives both an input for the retrieval tool to use and a set of filters, which are formatted into a query, which is given to the database to give a subset of the row IDs of the discharge notes to make the search faster. And then the retrieval tool then takes advantage of the corpus, the document term matrix, and the vector space model to produce an output cohort, which is in the form of row IDs again for the discharge notes. And then those are given to the front end, which queries the database again to retrieve the text corresponding to those IDs. And then they are showed to the user. So for evaluation, we randomly selected 100 documents from the dataset, and then we created 8 queries, and we looked at all of those documents and produced annotations based on whether they are relevant to the query in the form of just a binary relevance score. And as for the performance, on the query alcohol, there were 21 relevant documents in the annotation set and an R precision of 0.48. For smoking, it had an R precision of 0.55. There was only one relevant document on marijuana, but that document was not returned in the search. Smokeless tobacco also had one relevant document, but that was returned at rank 16. Heroin has 2 relevant documents, and they were both returned at the highest ranks, so the R precision was 1.0. Cocaine has 3 relevant documents with an R precision of 2 out of 3, so 0.67, and the third document was returned immediately after at rank 4. And methamphetamine had 0 documents in the annotated dataset, and only 1 document was returned by the search. And then finally, for transportation needs, there were 4 relevant documents in the annotated data, but it had an R precision of 0.